Hello, so this is the first part of review of chapter 18, Properties of Determinant. There will be 10 of them and I will review 6 of them in this video. So let me begin with stating that I will always go back into the 2x2 example because they are the simplest one. And one notation is that the straight line means the determinant of A. So when I do this, it means the determinant, and let me just state right now that the determinant of 2x2 in this case is this AD minus the BC. Although still we are not sure yet right now, like we're just memorizing this formula without even knowing where does this come from. So let me just leave it here and it will get clearer as I move forward in explaining all these properties. Okay, so let's start with the first one. The first one is really simple and straightforward. So the identity matrix of any size, for example, even the 3x3 or even the 2x2 or any n by n identity matrix has the identity I meant the determinant of 1. Okay, so that's the first one, and let's move on to the second one. So let's we'll still play around with the identity, but right now let's say I have the 2x2 case, and then if I switch rows, so I switch this to this and then this to this. So right now my identity here, so it becomes so initially it was 1, and right now let me name this P. So this become -1. So this is P stands for the permutation matrix, which what we were learning in the previous lessons. So permutation just sort of like playing around with how many possible positions of all the combination of all these rows and columns. So how about the 3x3? So that's interesting example. So let's start with this one. So again, I'm using straight line, so I straightly meant here the determinant, and then this one will equal to 1, and then if we switch one row, so the second row goes up, the first row goes in the middle, and we will have the -1 because it reversed the sign. Once again, it reversed the signs. And what about if we do one more row switch? So let's say we move the third row to the second row, and we move the second one down here. So this again will switch one row. So I did one switch here. So I switched the row, I switched the sign to the -1, and then I make another switch. So I switch again the sign to the positive. So please keep that in mind. And let's move on to the third one. Please wait while I delete all of this one and second property. So property number 3 talks about the linearity for each row. So let's divide it into 3a and 3b as what Professor Strang did also in the lecture. So let's begin with 3a is that multiplication of a single row. I think the word for single or each row is really important here. This is really important. So this is the case. So let's say you multiply the first row by t. So this will be equal to t and the determinant of the original matrix. So it's sort of like you're pulling the t out of the determinant. So a really quite interesting example here. So what happens if I multiply the matrix by 2, and so what is the determinant of that matrix? So it will be like 2 to the power of n determinant of A, and the n here is the number of rows. So why is that? So let's see. So 2a means, let me call this A, the ABCD matrix A. So 2a will be like 2a to B, 2c to D. So first you bring out the 2 from the first row, as per what we define here, the properties, but you still keep the second row fixed, so it has the factor of 2, but you pull out again, so right now you have 2 times 2, A, B, C, D. So this is really quite an important and interesting example of the property 3A. And let's continue to the 3B. 3B talks about addition for a single row. So let's name it the A accent. I'm not sure if I called that correctly. So A accent and B accent. And then this will equal to the original one plus that factor of addition. So the A accent and B accent while keeping the second row fixed. So that's about property number 3.